Hello! Today we're going to do a beginner's guide to flying the CRJ550 in Microsoft Flight Simulator. So this is the Aerosoft CRJ, or Bombardier as some people call it. It's quite a good aeroplane. It's not exactly study level, but it's kind of halfway between being a basic version of an aeroplane and a study level aeroplane. But there's lots to do in it, so we're going to have a look at it. We're going to fly it from Santa Barbara on the west coast of the USA up to Monterey, and we'll have a look through the systems and have a look at it in detail. So before we get started, let's have a look around the aeroplane. Oh, there's a truck in our way, which is useful. So you can see it's quite a big jet. It's obviously not as big as the big commercial jets like the A320 or the 737, or certainly not as big as things like the 747. So you can see on the ground it's obviously bigger than a Citation or anything like that. Obviously it can carry about 100 passengers, I think. So let's go and get inside and have a look at it. So there's lots of switches, most of them are working. There's lots of knobs and things to play with. So before I get started, I'm just going to go into the control options. Now this is really worth doing with any of the airplanes in Flight Sim. If you've got various different controls, is to go and configure them specifically for the airplane you want. So I'm just setting a profile on my controller that is specifically for the CRJ. And you might wonder why I want to do that, and it means things like on my hand controls, so you can see obviously my mouse isn't doing this, I've got direct control over things like the flap switches and the air brakes and various other bits and bobs. Obviously you can also use the stick, which is completely natural, and I can use the rudders by twisting my stick. I don't have rudder pedals. So anyway, so let's get going. Let's go and have a look at little Nav Map first. We are going to take off from Santa Barbara, which is just down here. So if we zoom out so you can see the western seaboard of the US. So we're just down south of San Francisco, just north of Los Angeles at Santa Barbara. We're going to fly out of here to the west, and then we're going to fly along the coast and then come into Monterey over the hills and do quite a steep descent in. We're still at 3,000 feet. So just out of interest, let's go and check if we show information for Monterey. It's at 200 feet, so we have to descend the best part of 3,000 feet in the ILS, which will be interesting. So we are going to use instrument flight most of the way, and we'll see how it gets on. We'll take over manual control during descent into Monterey. Okay, let's go and get this started then. Before we do get started, so we're going from KSBA to KMRY. Okay, so in the CRJ, the first thing we're going to want to do is go and switch on the battery master switch. Yep, so we don't know if we've got external power, so it'll behave as if we do not have external power. And we'll go and open the hatch for the auxiliary power unit and start the auxiliary power unit. So while we're waiting for that to fire up, we'll also go down here and we'll switch on the navigation systems, which is IRS, inertial, the inertial navigation system. So if we go and look outside, having pressed those buttons overhead, you can see a small panel has appeared here, and you can actually hear the APU. So the APU is a small jet engine in the back of the aircraft that provides electrical power and also compressed air to start the engines. So once the engines are started, the power generation will automatically cross-feed over to them, so they effectively work like dynamos, and at that point we can turn the APU off. So while we're sat here on the ground, we open the air inlet for the APU and we start the APU, and you can hear that happening. So if we go and look down in the cockpit, there's some buttons down here, so we can press ELEC here, for example, and we can look up here and you can see the APU is already generating electricity, which means we can sit here now quite happily on the ground and get the flight plan and everything programmed in before we even think about starting the engines. So in some of the smaller jets you have to really think about starting the engines first to provide electricity, unless you've got a ground power supply, which we're operating without one on purpose, just to see what's involved. Okay, so let's go and program our route while we're sat here. So position initialization first on the flight management computer. So we go pos init, and we pick up the current location showing from the FMS position, the Flight Management System position, and that puts it into the scratch pad, which is this area at the bottom. So that's where we can key things in. I can show you me doing that. I've just typed a G on the end. If I want to get rid of that, I can, if I can get the mouse to it, I can press the clear button. This is one of the bugs actually in the CRJ. You typically have to move this out of the way of the mouse. So if I press clear, you see the G disappeared off the end. So you can freely key into here using the keypad. But if you select something that's already there, it will put it in the keypad the scratch pad for you. So I've put that into the scratch pad, and now I can put it into the set position by pressing the soft key next to it. See, so it just transfers from the scratch pad whatever I've typed or copied from elsewhere into the field where I press the button. So I want to key in where I am at the moment. So you can say we said we were at KSBA, Santa Barbara. So we key that in, KSBA, and it goes into the scratch pad. Then we press the button next to the field. And there you go. It's picked it up, and in its database it already knows the location of that airfield. So then, typically on most flight management computers, you get the next stage required at the bottom right is selected for you. So we can just press Flightplan next. So we can see it wants an origin and a destination. So typically with fields on flight management computers, if they are squares, then you have to enter them. If they are dashes, they're optional. So KSBA to KMRY. So KSBA is the origin of our flight. And then KMRY, Monterey, is the destination. And it says it's 162 miles. So that's a good check that you haven't miskeyed something, is if the distance looks about right to you. Now it wants a 2 put in here. So we're actually going to ignore that, and we'll see, because I want you to see a discrepancy, or not a discrepancy. What's the word? I want you to see a gap in the flight plan. So we'll get to that in a moment. So we go to performance next. It wants a cruise altitude. We're just going to go to 24,000 feet today, and put in fuel. And we're going to say, we can actually work this out. So if we go and look in here, we can see this in pounds, not in kilograms, but we can switch this. Oh, it's only going to show us pounds, that's a shame. Do we get kilograms down here somewhere? We don't. Okay, so what we can do is say we've got, at the moment, 9,000 pounds of fuel. So if we go and open Google and we say 9,000 pounds in kilograms, 4,080 kilograms. Okay, so now we can use that. So based on what we've already got in here, we can put in 4,080 kilograms of fuel on board. We can now go to Vnav Setup, and we don't have to put anything in on here. There's no required things. And back to performance, we've already done that. Okay, so next thing we do is go and set up our departure and arrival. So you press the DEP-R button, and it's immediately asking for our departure information. So let's go and have a look at our map. We are going to be taking off on runway 25 out of Santa Barbara, and we're going to be doing the Gauche 2 standard instrument departure. So runway 25 and Gauche 2 is what we have to remember. So runway 25 and Gauche 2 is the SID, or standard instrument departure. Okay, so we've selected both of those, and we can execute that. And you can see it suddenly appeared on here. So it knows we're leaving and going that way, but it doesn't know anything else yet. So after that, it doesn't know anything. Notice it says 6,000A at the end of the waypoint Gauche. That means we have to be above 6,000 feet by the time we get there. Okay, so we can now go to the bottom left here, because it takes us back to departure and arrivals. And we can put in our arrival at Monterey. So if we go and have a look on the map and go and remind ourselves, go and double click on Monterey in Little Nav Map, and we can see we are going to be arriving. Let's have a look at our flight plan. We're coming along from the southeast, flying the approach in. So we will be arriving at runway, and it's directly in its way. You can't actually see it, but you can see on the label, runway 28 left. And we're coming in on ILS for runway 28 left, and we're following, if we open this out, the Rodney approach. Runway 28 left. So ILS, so it's not there on the list, so we go next page. It's not there, next page. Ooh, is it not got the ILS 10 right, RNAV 10 right, localizer 10 left? That's the same thing as ILS essentially. So we say that, and it is the only option. So that gives us that, and then we can execute that. And now we can go and look at legs, and you'll see what I was hinting at earlier. So there's the legs of our standard instrument departure. So by putting that departure in, it's already filled in a number of waypoints. If we go next page, there we go. There's a discontinuity between the start of the flight plan and the end of the flight plan, and you can see there's some vectoring as well, which we will get rid of. So just to make this a bit more interesting, in between the two places, let's go and fill in a VOR station. So there's one over here, look, PRB. So if we do this on Little Nav Map, we can just go add to flight plan and put in the Paso Robles VOR station halfway through our route, so PRB. So what we can do is key in PRB on the scratch pad and put it in the discontinuity. And it's inserted it directly into our flight plan, and notice it's made a new discontinuity below. So we can actually go and delete that. And where it says vect, we can delete that as well. And we'll just go and check previous, next, next. It all looks good. There's no gaps, there's no vectorings in there. And we can execute our change. And notice it has now filled in solid on the map. So on the map on the CRJ, you can, if I just, the control column sometimes gets in your way. If you click on the panel on the front of it, it gets shorter, just to move it out of your way. That's a simulator thing, really. So when we're looking at this map, we can use this knob to move the range, so you can zoom in and out. So you can see our whole route there if you zoom out far enough. Okay, so we have programmed our flight plan. Yeah, so we could leave that on the legs page now, and when you press legs, it goes to wherever you are along the legs. So obviously as you pass through them, it will start deleting them, as you know, the legs from the past get trimmed off. Okay, so you can see there on the engineering display here that there's loads of things that we haven't done yet. So there's like warnings essentially, and that's why we've got the master caution light flashing. So let's go and work through those. So if you remember up above, all we had done so far is switch on the auxiliary power unit. We've done nothing else. So seeing as we're sat out here on the parking, I'm going to fire the engines up while we're sat here, just so you get to see me do it without doing any pushbacks or anything like that. Okay, so how do we start the engines? Remembering we've already got the APU up and running, so we can literally just press start both engines, and you will hopefully hear them. If you go and sit outside, kind of hear them a little bit, but if we go and look on the displays, you can see they're coming up towards 20%, and they're going to stall out at that kind of speed. And I'm doing this kind of on purpose to show you what is dependent upon what. So that's the APU spinning the engines. Yeah, it can't actually do anything with them yet though, because the throttles haven't been opened. They're at shut off. So you lift the red lever and lift the throttle up. Yeah, so now I've got free movement of the throttles. Yeah, so I'm just going to release the reverser switches on my actual hardware throttles here, so I can't pull them any further than that. Yeah, so when I pull them back to idle, I get to the idle point. Let's move that out of the way again so you can see the throttles get to idle and they stick there. So let's just zoom in a bit further so you can see that. So the throttle system on this aircraft, it's got idle, climb, toga, which is take off, go around, and max power. okay. And if I want to, I can pull the levers up, and that gives me reverse thrust. Okay, so I'm going to leave them idle, and you notice the engines hadn't spun up any further than 25%. They're still sat with the APU spinning them on compressed air. They haven't ignited yet. And the reason they haven't ignited yet is we haven't turned on the fuel pumps. There's no fuel getting to them yet. So if we do that, now you can hear the engines spooling up in the background. And if we look down here, you can see the percentages coming up. So the N2 speed is the gas turbine. That's the centre of the engine. The N1 is the turbofan. So if you go and have a look at the engines from outside, they're quite a big housing, but the central part is the gas turbine. The outside part is the turbofan. Yeah, so you've got a jet engine in the middle driving a fan. It's a very efficient engine design. Okay, so we've done that bit now. So the engines are up and running and they're sat at idle. So if we want to now, we can actually go and turn the APU off. So you can see over here where it says avail at the moment on that APU button, we can go switch it off and close the hatch. This is the hatch button. So if we go and have a look, you will see that little door at the end is closing. It's in the vapours there. So we've now switched off the auxiliary power unit. We are using the jet engines to provide electricity to the rest of the plane. Okay, so next thing we can do, now we have the engines running, is switch on the air conditioning and turn on recycling of air. So it's quite an efficient system in the CRJ. It's able to recycle air around the cabin and filter it and push it back into the cabin, which is quite nice. Okay, so then we turn on the windshield heating to low. We arm the emergency lights. We turn on the seatbelt sign. We turn on the no smoking sign. And we then go and turn on the lights outside. There are some strict sequences for this if you were doing a real flight about what lights you can use where, but I'm just going to turn on nav, beacon and strobe all at once while we're sat here, just for simplicity's sake. Hydraulics, we're going to go and turn them all to auto, so you can hear that happen. And we're slowly getting there. So we've done most of the things overhead. So if we go and look down, there's still some more things to do. The yaw damper, the Mac trim, and the stab trim. So they're on the central console. So you've got the yaw damper, you press both buttons to enable it. Stab trim, again, press both buttons to engage it. Mac trim, just press it, and the inop button, the inop light goes away, and it's switched on. So if we now look up here, there are no more warnings. We are ready to go. Except we're not. We have to think in terms of the master control panel for the autopilot. So when we take off, we don't get any nasty surprises. So we can do that easily enough. We have got a flight plan programmed, which we're going to follow, so we can put the autopilot into nav mode straight away. So we can do this before we turn it on. We know the altitude we're going to climb to, and we're not going to do any kind of step climbs or anything today. We're going to go straight to our cruise altitude. So we put 24,000 feet into the flight management computer. So we're going to use the Alt knob over here, and we're going to watch this number here. At the moment it defaults to 10,000 feet that we'll climb out to. We're going to up that to 24,000 feet. So I'm rolling it, and that number's going up. And we slow down, and we get to 24,000 feet, so it's showing up there. So that's the target altitude for the plane to get to. We're going to climb there by using speed mode. So we switch on speed, and what this does, we can actually roll the speed knob, and you can see the number here changing. This is selecting the speed we want to climb at when we come off the runway. Now below 10,000 feet we are limited to 250 knots airspeed. Just by a convention, it's a law that below 10,000 feet civil aviation aircraft will not go faster than 250 knots. So we're saying in speed mode, try to do 250 knots. Now if it has excess thrust, in other words, if we are accelerating, what speed mode will do is lift the nose and keep lifting it until we're not accelerating any further. So it will hold it at 250 knots. So we can use the excess thrust we have, because we can go faster than 250 knots. It will use that to get altitude instead. So we'll see that happen. There is an alternative to that. You can use vertical speed mode, where you can dictate and say to the aeroplane, okay, I want you to climb at, say, 3,000 feet a minute. Yeah. But if you do that, then you have to control the throttle to keep yourself below 250 knots. Using the speed mode is a lot safer, because you're not going to overspeed. It will only ever get to 250 knots. It will just climb more steeply if it can go faster. Okay, we also need to get the flaps ready. So if we have a look down here, we can go and move the flaps. So the first setting is going to just do the leading edge of the flaps. You can see that happening here. If you go and look outside, you can see the leading edge has extended. If we go for the second setting, we get the trailing edge of the flaps has extended slightly, so you can see that's happened there. Okay, so that is good for takeoff. So next thing to do is come down here and release the parking brake. And you may even find the plane starts to roll on its own. No, it hasn't. That's good. The other thing we need to do is we turn this tablet on. There's some nice things in here. One of the things we have to do is release the chocks. If we look outside, there are wooden blocks around the wheels to stop it rolling, to stop exactly what I described. And look, I've removed the chocks and we are rolling. So in the real world, you wouldn't switch the engines on until you'd already removed the chocks, but we've done it already. So let's go and have a look at our runway and see where we are and see where we need to taxi. So we need to double round to the left, straight back onto the taxiway. So onto the rudder pedals, open the engine slightly, so we're just coming round. So here's the runway we're going to be taking off from. We're just going to roll over here, go around the corner and straight onto the runway.
The captain has advised that we are now cleared for takeoff.
There we go. So you get various voice messages from the cabin crew when you're controlling the aircraft in the CRJ. It's very good. So we just follow the taxi lines now out to the runway. Lots of cars in the car park today. I've got live weather on in the simulator. It's worth noting I programmed the flight knowing what the weather was going to be. I went and checked the weather before I planned it. If you fly with anything like VATSIM, this is something I came up with a friend recently. You may go and program your flight and think you're going to do it, and then you go and file it with air traffic control and they may go and give you a completely different flight. That's because each airport has an active runway, and you may not have considered the weather in the same way they have, or they may have other reasoning for using a different runway. Therefore they may discard the flight plan you have submitted and give you a completely different flight plan. Anyway, so we're sat here on the runway, engines are on idle, and we've started rolling. So let's gently open the engines. Remembering the autopilot is already set to nav mode, it's already set to speed mode. So we're just holding the centre line with the rudder. We're coming down 120 knots, 140 knots, and we rotate. And we're up. So then gear up, flaps up, and autopilot on. And you will notice now the plane will accelerate to 250 knots.
Too low, terrain.
We can actually watch this happening from outside to get a nice view of the aeroplane climbing out. So we're leaving behind Santa Barbara. We're on autopilot, so we can play around with the views and watch the scenery flashing past. So departing from Santa Barbara, and we should be turning sometime soon. If we actually turn the map on, we can see the route on the map, which is quite useful. Give the map a moment to appear. Here it comes. It should draw the route on, hopefully. Or maybe not. Okay. It's because I didn't plan it in the simulator menu. I did it in the FMC of the aircraft. But if we go and look inside, you can see we are climbing out until we get to the waypoint. Grr. And you can see we're coming up to 250 knots, and the plane is managing its own vertical speed to hold us to 250 knots. It can obviously go a lot faster in level flight. It's got the nose up and I'm still on max throttle. So what I'll do now is pull it back to toga. So that would be your normal takeoff throttle. I took off on purpose very quickly to show you that climb out ability. I'm going to pull the throttle back now to climb mode. So this is what's called a detent on the throttle. So it's an electronic throttle system that pre-programs the jet engines for climbing in a preset program that's efficient. So I'm now climbing, and you will notice it's dropped to 3.8, so 3,800 feet a minute, or 3,900. Look, it's slowly moving us around to stop us from going faster than 250 knots. Now remember, once we get to 10,000 feet, we can accelerate, and we can just do that by changing the speed on speed mode. So we're through 10,000 feet, and we can increase speed mode now for, say, 310 knots, for example. So the plane is actually dipping its nose, look, to accelerate. Did you see that happen? So it's come down to 1,000 feet a minute in order to accelerate. And once we get to the target speed, it will lift its nose again to stop us accelerating. So speed mode is a very safe way of climbing. On some aircraft it's called FLC mode, or flight level change. But you're basically telling the aircraft, I'll set the throttle, you look after pitching the nose up and down to match the speed I want you to do. So we're doing the turn at grrr now. So you can see way behind us now is Santa Barbara in the far distance. And we're turning out across the hills of California. And the plane will continue climbing up to 24,000 feet. Then it will level out, and then we will have to come off the throttle, because otherwise it will accelerate and go into overspeed. And on the CRJ you will notice there is a red marker on the airspeed ribbon, and that's the overspeed for the whatever altitude you happen to be at.
We are now serving sandwiches.
So now the flight crew have said they're selling sandwiches. We can go up here and we can turn off the seatbelt sign. Or you can if you can get the mouse onto it. There you go. So we're now flying out towards Gauche. And it's all looking good. We've got far more fuel than we actually need for the journey. Something we can do on this screen, each of the buttons down here controls what appears on the engineering screen you saw further up. So one way of doing this, so you get to see it, is I will hold down the right Alt key on the keyboard and click on that. And then I can come down here and show you what happens on each of these buttons then, in a nice easy way. So primary gives you that. Stat is that's the one you would normally leave on there, which is status of the aircraft. ECS, which is the environmental control system. Hydraulics, electricity, fuel, flight control systems, anti-ice, the doors, various other menus to do things which we don't really need to worry ourselves about, and we'll go back to stat and we can close that. But what that was actually doing was showing me that if you've got multiple screens, that's a huge tip, by the way. If you hold the right Alt key on the keyboard, the mouse turns into a magnifier, and you can break out any screen you want to be a separate screen, and then you could put that on a different monitor. Yeah, so that's worth knowing about. Or even you could use that, for example, and then within the simulator go to external view. But I'm not going to. I'm going to fly it as if we're flying the real thing. So we've got the status screen showing over there. Okay, so we're just coming up through 23,000 feet. The beep you just heard is warning us that we are within 1,000 feet of the target altitude. So the plane is starting to level out to stop the climb, and you can see it accelerating on the indicated airspeed over here. So we need to pull the throttle back now to balance that acceleration. If you look very closely, there's a small marker next to the speed. That's our rate of acceleration or deceleration. So I just move the throttle back ever so gently until we're not accelerating anymore. And there we go. So the plane's going to fly along quite happily. Oh, it started, look. Air is not consistent. That's the thing to think about. Air is a little bit lumpy, so you need to keep an eye on it. So we're flying quite happily now, about 320 knots. And I've pulled the engines back, if you look over here, to about 80%. 82% on N2, 80% on the turbofans. And that's it. So we're pretty much all set. So we can go and have a look on little Nav Map. If we zoom out, we can see our progress on the map. So we are flying up the coast now towards Monterey. The aircraft has reached its climb, its top of climb, and then on the screen down here on the legs page we get to see the progress of how far we have got. So you can see a countdown to the next waypoint. So the next waypoint would be PRB, which is the VOR station we programmed in. It's 331 degrees from us and 47 miles away. And obviously that's going to count down the entire time. You get a shortcut of it here as well. Yeah, so next to the compass rose on the primary flight display, you get the next waypoint showing up and how far away it is and its course. So you can see we are actually flying 330 degrees, but the course to it is 331. The reason for that is wind. The wind is hitting us 283 degrees, 14 knots. So we're being pushed sideways. So if we go and look on the map, oh, actually no, this is this is a good one. This is telling us that this is illustrating the difference between magnetic and true north. I think that there are quite a bit different from each other. Oh no, sorry, I tell a lie. Yes, it's correct. Take no notice of me. I'm misreading the instruments. So yeah, we're heading 331. The course is at 331 to the next waypoint. So we're all good. I'm just misreading the instruments, so take no notice of me. But yeah, this wind is not strong enough to really make a huge difference to us. We're being pushed sideways slightly, but not by very much. It's not unusual at 40,000 feet to get 90 or 100 mile an hour winds hitting you. So 15 knots worth of wind is really nothing to worry about. You can see in the aircraft it says TCAS off at the moment. TCAS is a traffic collision avoidance system. It does have it in this aircraft, but it's not really fully operable. So there are elements of this aircraft that don't work. It's a bit of a shame that it doesn't work, but there you go. It's on auto mode at the moment. So if I press that again, TCAS, you could say change it to TA only, for example. If we go and look up here, it will still say TCAS off. And we're overspeeding. Look, we didn't keep an eye on the airspeed and we can hear it. So let's just reduce the throttle and you can see the acceleration marker has moved away. What it's actually showing you is the speed you'll be doing in a number of seconds time. I think it's 6 seconds on most aeroplanes that do it. So yeah, TCAS isn't operational on the CRJ. Okay, so I'm going to stop recording at this point, or pause recording, and start recording again when we get closer to the destination. Otherwise you just get me talking about nothing at all for the next 20 minutes, which will be quite boring for you. So I'm going to have a look at the map to see where we are. I will start my descent a bit later than they say. So yeah, around about here, but I'll call you, or I'll start recording again when we're on the approach into Monterey. So, you know, somewhere around the Greenfield area, maybe near Miller's Ranch on this map. Okay, so I'm gonna go to OBS, which is a very good recording program, by the way, and I am going to pause the recording. Okay, so we are recording again. As you can see, we are still flying over California. You can see the hills out above, and you can see way in the distance is going to be where we will find Monterey. So if we go and have a look at the map to see where we are, we've made the turn at PRB. We're flying in towards Monterey. So we're going to begin descending. So to do that, we're going to use speed mode again, and we're going to set our altitude. Now if we go and just check on the map, we need to be above 6,100 feet when we get to the entrance into the standard approach route. So obviously this is calculated for the hills. So we'll go for 6,500 feet. So we'll pull the altitude down. We're watching this number over here. We'll pull the altitude down to 6,500. So 6,500, and we're going to do it in speed mode again. So if we hit speed, all we need to do now is pull the engines back. So as soon as we slow down, to maintain the speed we have set, which was the speed we were at when we pressed the speed mode button, seeing as we have no thrust now, it's dipping the nose to keep us at the speed. So something that's worth doing on the way down is to reduce that to 250, remembering that when we get to 10,000 feet we're going to need it to be at 250 knots anyway. So we'll just reduce that. So what the airplane's doing now is lifting the nose to reduce the speed to get to 250. It's just doing it very gently. Yeah, so the plane is lifting its nose to decelerate because we have no thrust. Obviously if we want to come down very steeply, we can just drop the air brakes, and that means we can really descend fast. But we shouldn't need to do it. We'll keep an eye on it. One thing that's worth looking at in Little Nav Map, because we're just coasting in now, we can show the elevation plot. So you can see there's our flight plan. We climbed up remarkably quickly because we were on max power instead of climb. So you can see, but as soon as we went to climb, which we did quite late, you can see it leveled out. But now we're coming down, and we're not coming down fast enough, look. But that may increase. Now we've got to 250 knots, so you can see 2.2 or 2,200 feet, 2,300 feet a minute, 2,400 feet a minute. So it's stabilising it at 250 now. Now it's got to 250 knots. So you can see that line is getting steeper. It's difficult to tell sometimes, but if we do want to come down much more steeply, all we need to do is pull the air brakes on. So I've just extended the air brakes, and you can see the nose is dropping 2,900, 3,000, 3,100, 3,000. So that has increased our rate of descent just by dropping the air brake, because we are in speed mode and it's trying to go to maintain 250 knots, and it's doing that by dipping the nose. Obviously if we open the engines up, then the plane will level up. It won't descend anymore because it's going to do 250 knots. You know, it's not going to have to drop to do it. So let's have a look at, so you can see the line converging now on the descent rate here. So we could actually release the air brake now. and obviously it's dropping right back to until it stabilizes again to about 2,000 feet a minute. It will waver until it stabilizes as it hunts to find the best angle to maintain 250 knots. And you can obviously see now on the display what's going on. So again, we didn't really look at some of these buttons. The ones that are important to you when you're starting out with the CRJ are the range, obviously, to make this zoom in or out, and nav source and the barometric pressure. So something we need to be mindful of is to go and look at the information for Monterey. We've actually got it here, and we can look at their METAR. This is the METAR readout, the atmospheric conditions at Monterey. So what we're looking for here is that 3009, which is the atmospheric pressure. So you can see that, well, that doesn't make sense because this is 1013. What we need to do is press the HPA or inches button. So that's hectopascals or inches. In America, it tends to be measured in inches. So it's 29.92, but we want it to be 3009 to match the ground reading. So we can roll this knob to increase that to 3002. 3009, sorry. So 3009. Did you notice that the altitude was stalling as I did that, the descent? That was because we are calibrating the altitude, and the altitude is measured by atmospheric pressure. So we have been changing the altitude readout to match an accurate reading from the ground. So let's go and have a look at our flight plan here. So we're coming down about the right rate. We're going to need to be careful. We might come down too steeply, in which case those hills will become an issue, which is why it says to stay above certain heights. So this, remember the way we've configured it, we're dropping to 6,500 feet, so we can't just continue dropping. So what the autopilot will do is when we get to that target altitude, it will level us back out and we will need to increase the engine. At the moment it starts leveling out, it will cut off speed mode and we're back in control of the engines to maintain our speed. Because all the autopilot's going to do is get us to 6,500 feet, and then it will go to altitude hold. Yeah. So we're just flying straight down here, and then we'll make a left turn at Charlie into Monterey. Something else that's worth checking is the ILS reading. 110.70 is the ILS for what was it, 28 left. So 110.70 is the radio frequency. So let's go and check that while we're descending. If we click radio on the FMC, we can see at the moment Nav 1 is on 114. So let's go and check that, change that to 110.70. The reason Nav 1 is on 114 is because we programmed the VOR in earlier, if you remember. Let's just go and check that none of the waypoints are VOR stations. They are not. So we wanted 110.70 on Nav 1. Notice Nav 1 has now changed. And it's on auto, which might mean it will pick it up when we get closer. So let's leave it for the moment. I mean, we could do it ourselves. 110.70. Let's try it. 110.70, and let's put that into Nav 1. So we've now programmed Nav 1, which the ILS will, or the autopilot will use for ILS, into the system. Now we're getting lower. Look, we're down to 8,000 feet, and those hills are looking mighty close. So we are below the recommended glide. So what we're going to do for the moment is do an altitude hold, because I don't fancy skimming down the edge of these hills too low. So we'll continue speed modes. Notice the speed is dropping off because we are in control of the engines, and obviously it's not descending anymore, so we're slowing down now. So just crept the engines open to get us back to 250 for the moment. And while we're at it, we will also zoom in this screen so we get some idea of where we are and what heights we need to be at along the way. So we're still at 7,200 at the moment. So we can start descending again, go back for speed mode, and we will cut the engines again, which will begin the plane dropping, because obviously it doesn't need to maintain 250 knots, or 252 it's on at the moment. If we go and put 250 in, to maintain that speed it's going downhill with no engines to try to keep at 250. But notice it stopped doing it. It's because we're within 500 feet of the target altitude, the plane's levelling out. So we need to start increasing thrust ourselves to maintain 250 knots. And we're turning left. So this is why there was the 6,500 feet limit. It was to clear these hills by 1,000 feet. And you can see now, out ahead of us, you should see the airfield. So we can continue down now to 4,000, 5,500 and 4,000 and so on. So we go for 4,000 for example, or it was 3,000 at the start of the ILS, wasn't it? So I've programmed that, and I go speed mode, and I cut the engines. And we begin falling again. So the other thing we can do now is we're going to switch the display over to use the nav source, the ILS that we programmed. So I've switched it from, you can say it says FMS, we can switch it to LOC, which is localizer. So now this is showing the runway in the distance. So I can go to approach mode now. So it's still dropping to 3,000 feet, it's in speed mode, but we're on approach mode. Approach mode means it's following the radio for the runway. Now we need to start losing some speed because we're getting close, we're within 10 miles now. So let's drop this speed right back. And to do that, what it's going to do is lift the nose, but we want to carry on descending, so I'm extending the air brakes to get rid of the speed. I can also start to deploy the flaps. So I've pushed out the leading edge of the flaps, and here comes the warning about overspeeding because of the flap position. We're coming down, we're at 4,000 feet. So let's just straighten the screen up a little bit so you get a proper view of things happening. Now this aircraft does have a head-up display. I'm not going to use it because I think it's more valuable for you to see me explaining things on the instruments as we go. Okay, so now we're down to 200 knots. I'm going to drop the wheels. And I'm going to come off autopilot now, and we'll fly the last bit together. So you get to see this happen. So I'm holding it at 3,000 feet. I'm losing speed on purpose. So the beep was us getting close to 3,000 feet. Yeah. So I'm going for the next stage of flaps. You can see the runway ahead of us. Just. And the next stage of flaps, we come off the air brakes now because the flaps are very good at retarding us because they are they're very draggy in their own right. Obviously the flaps are obviously providing a lot of lift. They're trying to lift the nose up. So we've gone slightly to the right. I'm surprised. There seems to be a problem with the ILS. The frequency hasn't picked up. We should have seen indicators on the main display, and we haven't. So I'm going for full flaps. So this is essentially a visual landing then. So ILS has failed us for whatever reason, and we're landing it by hand. So we're keeping an eye on the indicated airspeed, which is 140 knots at the moment. We don't want to get much slower than that. We only need a touch of throttle for that to happen. So we're fully manual, we're just watching the runway. Full flaps. Accelerating a little bit too much. So we're going to basically get to the runway and then pull the throttles to idle and flare it out.
400.
So it's just about concentrating on the runway, the centre line, rate of descent, indicated airspeed, and not panicking really.
200. Sink rate. 100. Sink rate. 50. 40. 30. 20. 10.
And we're down. So we can hit reversers. Which are not slowing us down tremendously quickly, so then we can use the wheel brakes as well. And we can exit the runway. So we'll exit to the right. For no particular reason, just because I picked right. And we'll just pull onto the taxiway and end the flight on the taxiway, I guess, because there really is no value in seeing a power down. There we go, they're telling the passengers now, get ready for the mad rush for the terminal. I've never quite understood why passengers are eager to get off an aeroplane, because most of you are going to have to go and get your bags anyway, or wait for them. So let's just pull around here to the right. Get out of the way of the traffic. The warning we saw then was just me opening the engines too much to begin accelerating, so it looked at the flaps and thought, you're not configured for takeoff, what are you doing? So there you go, that was the CRJ in Microsoft Flight Simulator. It's a very good aircraft, it's made by Aerosoft, it's not too expensive, and it gives you a really good introduction into flying commercial jets. So obviously you saw today, you can't always rely on ILS, and you shouldn't rely on it, because you saw, had the right frequency, everything was plugged in, and it just didn't work for some reason. So it may have been something I did, not entirely sure, but there we go. So I'm going to go and put the wheel brakes on, and you can see the aircraft come screeching to a halt. And obviously, to reverse the process of firing the engines up and everything, we just go through that backwards, basically, to power the aircraft back down again. Oh, you can see we're getting a warning about the brake. That's a discrepancy between this particular aircraft doesn't like the mapping I've got for the parking brake on my controller. It's fine, so it likes you to use the one that's in here. But yeah, it's a good aircraft. One thing, a bit of a tip, although I'm not going to go all the way through it because it'd be very boring to see it happen. On the real aircraft, on the taxi back, you will often see the pilots operate or fire up the APU again. That's so when they are switching the engines off, they don't lose electric power. Yeah? So you'll often see the pilots firing up the APU on the taxi back. So a bit of a tip there to do that. As soon as you pull off the runway, fire up the APU, and then during the taxi back it will be up and running. So when you get to the gate, you can power your engines down and you still got electrical power through the APU, so then the APU becomes the last thing you switch off. Okay, so I'm going to leave it there. So this was the CRJ. Hopefully that's been a good taster for it. It's not very expensive. You can go and get it for Microsoft Flight Simulator and have some fun in it. And it can travel for thousands of miles, so it's good fun flying, across continents. Okay, I'm going to stop there. I'll see you all again soon.